Okay, hi Chem 30. I'm going to do a lab demo with esters and a short lecture on esters that I'll post today as well. We'll do the demo in a separate lecture. So we talked about carboxylic acids and alcohols yesterday in yesterday's lecture. Esters are on page 439 of your textbook. Now, esters are organic compounds actually formed by the catalyzation of the combination of carboxylic acids and alcohols. So esters are a combination of carboxylic acids and alcohols. They can be natural or synthetic. Most of the fatty acids and fats in your body are esters. Plants, scents, flavors, artificial or natural, are also esters. So I'm going to make an ester reaction that will create a wintergreen flavor. Unfortunately, you guys are not going to be able to do this yourself. The way that esters are formed is, so if you see the ester reaction in the functional group formula, it's an alcohol plus a carboxylic acid, and we use dehydration synthesis. So you can see that there's the OH part of the carboxylic acid and the H of the alcohol, and H2O is removed with a strong acid. So this is, if this was as accurate as it could be, this would say H3O+, but we use an acid to dehydrate these two molecules to open bonding spots up to make an ester. So it's alcohol plus carboxylic acid makes ester plus water. So the functional group for an ester, sorry, that is incorrect. Okay, so the functional group for an ester is this, where we have a C double bond OO in the middle of two carbon chains. So this would be a carbon chain here, and this is a carbon chain here. But you have this single bond O, double bond O right in the middle of two carbon chains. Okay, the side with the single bond O is the alcohol side. And the side with the double bond O is the carboxylic acid side. That's important when we name these things. Okay? So here's a whole bunch of ester examples. All right? These are a lot of common flavors. You can see the single bond O, the double bond O, single bond O, there's a carbon right here. Okay? You can see raspberry flavor, pear flavor, right? This is ethanoic acid and propane. Acetic acid is ethanoic acid. Apple, orange, pineapple flavor, rum flavor, banana flavor. You can see there's always this single bond, the double bond O, single bond O with the carbon chains on either side. You can have benzene as well. Okay, this is methyl salicylate or wintergreen. I'm going to make wintergreen flavor. This is salicylic acid with methanol. All right, so there's some common ester examples. Naming esters, I'm going to give you a bunch of examples here. So you find the ester functional group, draw a box around it, circle each chain of carbon atoms that extend from each functional group. Locate the chain of carbon atoms that is attached to the functional group by a single bond to an oxygen. This is the alcohol part. Identify the number of carbon atoms in this chain and then name that YL. You're going to name that first. Count the number of carbon chains in the second chain, starting with the carbon that contains a double bond to an oxygen atom. So that chain will become the carboxylic acid. Okay. Identify the number of carbon chains in this chain and use the following prefix. Use the appropriate prefix with the carbons. And this is going to be so pentan or propan. And the way we finish off naming an ester, this is the alcohol portion, and that's the carboxylic acid portion. So you have, rather than ethanol, ethyl, and then the carboxylic acid portion becomes O8. Okay, so those are your naming rules. Here's some naming examples. Now, page 441, numbers 3 through 6. Page 443, numbers 3 through 8 address esters specifically. But this is how you do it. So I have a double bond O here and 1, 2, 3 carbons. That's the carboxylic acid side. It's in blue. Okay. Then I have the red part here. This is by the single bond O. There's 1, 2 carbons. So this would be the ethanol. So the ethanol is red. So the ethanol becomes ethyl, and the carboxylic acid is propanoate. So ethyl propanoate is the appropriate way to name this. And you can see this here too. Single bond O is the alcohol. The double bond O is the carboxylic acid side. So this is methanoic acid, and that's propanol. So this becomes propyl methanoate. Okay. Right, you can see methyl butanoate. This is methanol and butanoic acid. Propanol and ethanoic acid, propyl ethanoate. So here's how we name esters. Ethanol plus ethanoic acid makes ethyl ethanoate plus water. Right, propanol plus ethanoic acid makes propyl ethanoate, and then water will be on the end of that as a product as well. So you get the drift. The alcohol becomes YL. So whatever butanol is will become butyl, right? Or whatever alcohol is will become alkyl. And then the oic acid becomes O8. Okay. Those are all the notes on esters, but let's look at some examples. So let's say we have butanoic acid plus methanol. So we have these two molecules. This would be C3H7OH. Right, and this is CH3OH. If I were to draw this, right, this is I'm not going to put all the hydrogens in there, but that's what this is. And then the methanol, right, would have the hydrogens attached to it as well. So strong acid, so a strong acid catalyst would make my products. Okay, and we're going to remove an H and an OH, and we make water as a product. So H2O plus whatever this is. So this would be the alcohol portion, so this would become methyl. And this is the carboxylic acid portion, so this would become methyl butanoate. And my molecule would look like this. Right, and then I would fill in my carbons. There's 1, 2, 3 carbons attached here. Okay, and that would be my molecule. All right, so that's an esterification reaction. All right, so let's say we have this one. So 1, 2, 3, 4, that's butanoic acid. This is 1, 2 carbons. Okay, so that is ethanol. Use a strong acid. We're going to produce H2O. And then this makes okay, so 1, 2 carbons here and 1, 2, 3, 4 carbons there. So this would be ethyl butanoate. Okay, typical esterification reaction. Okay, so examples. Write structural diagrams and name all reactants and products. So A, we have ethanoic acid. Plus ethanol. So that's what reacts. You get water plus, the strong acid will treat this, and this will be ethyl ethanoate. Okay, ethyl ethanoate. So the structural formulas are going to look like this. So this is ethanoic acid plus ethanol. Okay. This makes your HOH plus one, two, plus the ethyl ethanoate. Okay? Let's say we have butan 1-all plus methanoic acid. Other thing with esterification reactions is you do need to have your hydroxides and the alcohol on the ends. You can't pull it from the middle, or else it will mess up the ester bond. So it always has to be a hydroxyl group on the end of the molecule. So this is one, two, three, four. And you have a hydroxyl group attached to that. So butan 1-all plus methanoic acid. Okay, that's your molecule right there. What do we make? Strong acid dehydrates the molecule and creates HOH plus, this is going to end up being this ends up being butyl methanoate. Okay, butyl methanoate. So it looks like this. 1, 2, 3, 4. Okay, and that's your line structural diagram. Let's say you're asked in this way. Write a chemical structural equation to show how the following are prepared. Name all reactants and products. Okay, so here's what we have. Ethyl methanoate. So how do we even make that? So I need to have, methanoate, I need to have methanoic acid. Plus ethanol. right? Okay, so plus ethanol. I could express. So this diagonal line indicates there's a hydroxyl group, but I could also just put it like this, and there's 1, 2 here. All right. So plus ethanol, I need a strong acid, and this is going to make HOH plus my methanoic acid, and then my ethanol right there. Okay, so that would be the product. Let's say we have this one. Methylbutanoate. So this would be methanol plus butanoic acid. Okay. And that is this, right? So methanol plus butanoic acid right, so I have a complete structural diagram and a line structural diagram. I'll just combine the two. H3O plus, I make HOH as a product. And then here's what we get. One, two, three, four. And then I have the methanol on the other side. Okay. Okay, what about this? Name the following esters and starting materials. So let's say we have this. Okay. So I have 1, 2, 3, 4 molecules attached to the oxygen here. That is butanoic acid. And then this is C2H5, right? So that's two carbons. There's 1 hydrogen attached to the oxygen, so there's 5 other open bonding spots for hydrogen. So the 2 carbons is ethanol. Right, I'm going to make water, and the name of this molecule is ethyl butanoate. Okay. Let's look at this one. So you can have side branches. And that's what this one shows. Okay, so there's your skeleton equation. This side is the carboxylic acid side. There's 1 carbon, so that's methanoic acid. And then this side, that's the longest chain. That's pentanol. And then it's 1, 2, 3, 4, 5. So that's a methyl group on carbon number 4. So I'm going to number my carbons from the functional group out. So I have 4-methyl pentanol. Okay, and those are my initial products, and right, we make water plus from this esterification reaction. This is pentyl methanoate. Okay, pentyl methanoate. Sorry, that's not correct. This is 4-methyl pentyl methanoate. Okay. Okay, let's say you're given this guy. Okay, so carboxylic acid side is 2 carbons, so that's ethanoic acid. This is 3 carbons, so that's propanol. That's the alcohol side, right? Strong acid, water created. This is going to be propyl ethanoate. Okay. Let's look at the last one here. Okay, so this is a benzene, and remember, benzene that starts as an alcohol is called phenol, right? So that's called phenol. Talked about that in the alcohol lecture yesterday. This is the carboxylic acid side, and this is the alcohol side. And we've gotten rid of the hydroxide and have the single bond O now. So this is propanoic acid. And this is phenol. So to get rid of the alcohol, I turn it into phenyl. So this becomes water, obviously. And then I have phenyl propanoate. Okay, so benzene is fair game here. I'm going to give you another example of that when we talk about the lab itself. Okay, those are esters. I'm going to do your ester lab in another video. We will talk to you soon. Bye now.